And I think we might have done a couple of these together. Now here you have your vertices, which gives you the distance from your center to your vertex point. So that's your A. From your center to your vertex, that's A. Your foci, from your center to your foci, that's C. And you're going to use your formula to find B. Now remember when we did it on Friday, all we needed to do was find B squared. We just had to find B squared. That's the guy that we're putting in here. Remember that the numerator is squared, the denominator is squared. Good way to remember it. Stop me if you have any questions. The major axis again is your x-axis, so underneath the x in that denominator has to be the larger number. So your foci is your C. Now the length of your major axis, the entire length is 14. So from the center to one vertex is half of that. There's your 7. So your A is 7. Good? So your 7, you find your B, and again, all you needed was your B squared. They started out nice. They started out using the center as a 0, 0, so you didn't have the confusion of your center changing. So that was kind of nice.
Wait, do you have to simplify the radical 24 into 2 radicals?
No, you don't, because all you really need is your B squared. You only need B squared to plug in here. So you didn't even have to simplify it, because what they asked for was an equation. If they asked for your length of your minor, then if they said what is the length of your minor, then you would have had to simplify this into radical 6. But because you're just going to plug in your B squared, I wouldn't. It's double the work. You're reducing, then squaring again. Okay? All right, this one was a nice one, a little different. Your vertices are at 0, 5, 0, negative 5, so you got a y, guys. So underneath the y is that difference, 5. So start like that. You know he's got to be the larger one. Now, they said it passes through a point. A point. That means your ellipse is going to pass through that point. It's going to have a center of 0, 0, and at 4, 2, it's going to go like this somehow. Or actually, it's long ways, right? It's going to go like this somehow. It's the long ways. So now, you have to find out the remaining parts. That's just like we did with your parabola. That's an xy point. So therefore, plug in your x, plug in your y, and isolate b. That leaves you one variable. You know what your a is. So plug in an x, plug in a y, and isolate the b. Now when you get down to here, yes, I realize it's a fraction. So God bless you. When you get down to here, it looks like this. Put this 1 over 1, multiply everything through by the common denominator, 25b squared. Out comes your b squared, 16 times 20, 400. Out comes your 25, 4b squared. This guy is 25b squared. Get all your b squareds to one side. Subtract 4b squared. And divide by 400. You're looking at this right now. Oops, sorry, divide by 21. There's my b squared. You're looking at this. 400 over 21. Now, you could take the square root to find b. You don't need to. All you needed was this guy. So this is going to slide right in here. Now, if you left it like that, I'm okay with that. Because technically, the coefficient of x is 1 whenever we need to find your minor or your major. If you flipped it over, that's fine. You brought 21 to the other side. In other words, if you multiplied the top by 21 and the bottom by 21, you got this, 21x squared over 400. If you did that, that's fine. If you left it with a fraction in the denominator, I'm okay with that. Okay? There was a lot going on. Okay? vertices and vertices. That means you got your major and your minor. How nice was that? That's all we needed. Oh, and they offset this. So you just had to find your center. Remember, the center is in the middle. And to find the middle, the mean of something, add them together, divide by 2. So add the x's together, divide by 2. Add the y's together, divide by 2. And then you find your center.
So what we're doing is we're always finding B.
You're always finding A and B. You need to find your A and B. The formula that we use for this will help us find, if we're given, say, C and an A, we can find the B. If we're given if we only need A and B, that's all we need to do. We never have to find C. If you're looking for the equation.
So A's from the center to the vertex.
A is from the center to the vertex. And you got to figure out which one is your major. So this one's your major, so it's got to be under the Y. That's your major one. That's got to have the bigger denominator. Okay. Find your center. Can everybody find the center? Yes? Okay, 29. Again, your minor axis this time is the length of it is 2. So from the center to the co-vertex is 1. That's going to be what your B is, 1. And squaring 1 is 1. Find your center. Did I add this information here, or did you figure that out? I think I might have put it on here. Okay. Foci in the next one. Foci gives you your C. God bless you. Again, with your foci, find your center, because your center is in the middle of your vertices, your co-vertices, and your foci. We only do ellipses that are symmetrical. We don't do ellipses that are off-center. God bless you. And again, you didn't need the square root of B. You just needed B squared. All right, 33 and 35. Vertices, minor is your B. Make sure you split it in half. When you find it, make sure you square it. The numerator squared, the denominator squared. Find your center. Smack in the middle. I find the sketches are very helpful. You'll know which one is your major and your minor as soon as you graph it and see where it's lined up. So as soon as I see my vertex lined up vertically, I know that's my major. Got it. My co-vertex, my minor. Now this one was a little bit different. We gave you this formula. A is equal to 2C. So if you found out A, because you can find out what your major length is, God bless you, and your major length goes from the center to the vertex. You found out A was 4. Just plug a 4 right in here. Obviously, you can't find B yet. So if you found C, then you can use your formula. So plug the A in here. Find what C is. C would be equal to 2. Plug that in. Then all you need again is your B squared. Some of these you had to think about a little bit, play with a little bit, right? But for the most part, isn't this a lot easier than the parabola? Kind of more straightforward. I think it's a little less room for error. And that was it, right? Okay. Okay, you've probably seen a hyperbola. When you did inverse proportions, when something varies inversely, you did x times y equals some constant, whatever constant you had. It gave you a hyperbola that looked like this. Either like that, or it went in the other two quadrants if it was negative. If you kind of picture this, kind of like a box. This is what your hyperbola is going to look like. So we're going to be talking hyperbola in a minute here. This is a terrible diagram, I realize. Get this back. So your hyperbola is going like this. All right, so if you picture this tilted, we're going to do a hyperbola, kind of like the same situation, but off of your axis, which makes it so much easier. Your hyperbola is going to have a center. Your hyperbola is going to have an A, B, and a C. And it's going to have a focus of two focus points, so foci. It's going to have a major axis and a minor axis. But it doesn't really have a minor axis because when we make your hyperbola, the vertex will sit on your major. We need a cold vertex to make the box, but we don't put your hyperbola through it. So even though we find your minor and we find it cold, it's not, God bless you, it's not really a cold vertex because it doesn't touch your hyperbola at all. And we'll talk about that in a second. Now, what separates this? If you looked at this formula, how is that different from your ellipse? It's a minus. Good. It's a minus. It's still equal to 1. I still have an A and a B, but it's a minus sign in between. What about the difference from these two, where one is a major and one is a minor? What's changing?
The X and the Y.
The X and the Y. Good. Not the A and the B. The A and the B are still in the same place. Remember your ellipse, didn't the A and the B change depending on who was the major one? On your ellipses, we did this. And we said whatever one was larger, so it technically could look like this. The order of this did not matter because it was commutative properties. Now, the best way to remember a hyperbola is it's a subtract. So it matters what one comes first. Because if I subtract 5 minus 3, I don't get the same answer if I subtract 3 minus 5. So what you need to remember is order matters. The major axis is the first one, regardless of A and B. So that's why Vanessa realized they switched the X and the Y. The A and the B changed. So A is always going to be your larger one. No, because it's going to come first on your, your order. But what's going to make a difference is which one is it, the X or the Y. Okay. And to throw a little curveball in here, we have this beautiful asymptote equation. And it looks pretty scary, but it's going to be a lot simpler than that. Again, I'm not real big on memorizing formulas. I'd rather have you use your diagrams and figure it out. The one thing that is different is finding your foci, your C. Instead of subtracting it like your ellipse, we're going to add it. And I'm going to show you why in a minute. Okay? So let's try one and see what it looks like. Don, do you have this on your paper? No. I'm going to start off with one even simpler than this, so don't write this one down yet, okay? Okay, let's start like this. Okay. Ellipse. It's an ellipse. Because why, Aaron? Why is this? This is an ellipse? What is it? It's a hyperbola. Good. Oh, see if you're awake back there. You're busy talking. Okay, it's a hyperbola because why? What? A minus. Good. The ellipse has the plus sign. It has the same look to it, but it has a plus sign. So, again, it matters who comes first. So our X is going to be our transversal axis. We call this our major. This is where your vertex are going to be located. So this guy is a squared. And this one is b squared. Oh, you can put it right there. Thanks, Albert. All right, so now, what's a? 4, square root. This is squared, square root. What's b? 3. Now, I need to find c. C says a squared plus b squared. So I know my a squared, I know my b squared. And so therefore, what's c? 5. Good. So I know my pieces now. And my center is where? 0, 0. Okay, so let's start graphing this. Here's my center. A is going to be my transversal axis, my major axis. So I'm going to go out 4, put a vertex, out 4, put a vertex. Transversal means this is where the hyperbola transfers off of. It's going to go this way, where the vertex is. It's not going to touch the y-axis at all. But we need to use the concept of your co-vertex because we need to make a box out of this. So we come up and down 3. It's not really a co-vertex, but we need this to make a box. So now we make a box out of this. And we send an asymptote through this. We send a diagonal through this. It goes from one corner to the other corner. It goes out like this. You make a diagonal in your box. Somehow, close to your edges. I think my board's off a little bit. Now, off of your transversal axis is where we make the hyperbola. Here's your vertex points. Watch how we do the hyperbola. It's like 2 little parabolas. This asymptote is our guideline. Just as we did an asymptote when you had something you couldn't use in your denominator and it never touched that number. It's not going to touch this line. We're going to use this as a guideline to go like this. How easy is that? This is all there is to making a hyperbola. So we have a vertex at -4, 0, and 0. Now, where did your foci sit for your parabolas? Do you remember? Your focus point. Inside. Therefore, this is like encompassing like a parabola. This is where our foci is going to sit, right inside. That's why we add them instead of subtract them. And that's how you can tell when you make a mistake. If you by accident add them on an ellipse, it's going to come outside of your ellipse. So you have to subtract them. If you accidentally subtract them on a hyperbola, it's going to come inside your box. It's got to come inside your parabolas. So therefore, we add them. So this guy is going out 5, 0. And this one's going out -5, 0. There's your foci. The only other thing we have left to do is the equations of this line. We just have to find the equation of your line. Now, we start with y equals mx plus b. This is how I start. B is where it intersects the y-axis. What's the point right here where it intersects the y-axis? 0. So we can take this out of here. Now, you have to find your slope. Your slope is the change of y over the change in x. Now, the y guy is right here. Here's your y. What's the square root of 9? 3. Your x squared is right here. What's the square root of 16? 4. So your slope is y over x. 3 over 4. You went up 3 and over 4. See your slope? square root, and I'll go over the other one again. It's the square root of your denominator of your y, the square root of your denominator of your x. That's your slope. Change in y over change in x. So we say, okay, that's going to be 3/4 x. And this guy, that's this one. What's this one going to be? The other one? Negative. So there's your plus and minus comes into this. We didn't have an intercept other than 0, so we were okay starting with this one. Now, your formula says x minus h. Now, our y and our x are just the variables that stay. Our h and k are your center, which is 0, 0 this time. 0, 0. So there's your y equals, there's your plus or minus. This guy right here is your slope. There's your slope, 3/4. Your h is 0. So there's your x. Okay, so we can follow your formula. We can kind of look at your graph. Now, the only time we have trouble is if we have an intercept somewhere. An intercept gives us a little bit of trouble, but we'll work through that. Okay with this? I realize I'm kind of running out of time. I wanted to do one more. Questions before you start? Before we go on to the next one? I guess it's not questionable. Okay.